Okay, let's move over to matrices. Matrices are vectors with a dimension attribute. The dimension attribute is itself an integer vector of a length of 2. That is, we have a number of row and a number of column. So instead of a vector, we have 2 dimensions, rows and columns. Okay, that's a very simple definition of a matrix. To create a matrix in R, or a matrix in R, is very simple, right? You need to issue the matrix command. You give it a number of rows and you give it a number of columns, and that creates an empty matrix. Let's look at an example. So we can create a matrix named M and assign it 2 rows and 2 columns. If I issue that, you'll see I have now a data set or a matrix named M. It's currently a logical data set or a matrix because we have no values in it. And you can see that it has 2 rows indeed and 3 columns. If I look at the dimension, it tells me the rows and the columns. So matrices are constructed column-wise, and in general in R, everything is constructed column-wise. So entries can be thought of starting in the upper left corner and running down the columns. If I create a matrix of 1 and 6, again, we're using the range notation between the number 1 and number 6 with 2 columns, 2 rows and 3 columns. It's going to fill in starting from the upper left side. So 1, 2, 3, 4, 5, 6. Let's see this example in RStudio. We're creating a new matrix. Remember, when you assign an object to the same object name, it's going to overrun the previous object. So now you can see we have a data, and it becomes an integer data set, and it has the numbers 1, 2, 3, 4, 5, 6, and for each column 1, 2, 3, we get a set of numbers. Very simple. A convenient way to create a matrix or an array is to use the matrix and array functions respectively. Below, we will create a matrix from a sequence of 1 to 16 in 4 rows, so the number of rows will be 4, and fill the matrix row-wise. So by default, the by row equals true rather than, we will define by row equals true rather than the default column-wise. When using an array command function, we can define the dimensions using the dim argument. In our case, 2 rows, 4 columns, and 2 different matrices. So let's look at these 2 examples. First of all, we'll create a my matrix ranging from number 1 and number 16. We're going to have 4 rows, and the by row this time is going to be true. So it's going to go row-wise. Look at what happens. Instead of going column-wise, which is the default, it started filling in the rows 1, 2, 3, 4, all the way up to 16. Now, if I use the array command to create an array, again, numbers 1 to 16, this time I can give it a dimension argument. So saying dimension equals C of 2, 4, and 2. And when I create this array, my array, we're going to see that we have 2 separate matrices in the array. One with 4 columns on the upper side and 2 rows. And the other one, the second one, denoted here as number 2, again, 4 columns, 2 rows. Okay, and you can see it kind of went and filled the numbers through the first array, for first matrix, the second matrix to create an array. Sometimes it's also useful to define row and column names for your matrix, but this is not a requirement. As you've seen, we didn't define names and it worked. To do this, you use the row names and column names function. So you can take the same matrix that you created and again assign it a vector and this time it's a character vector, and it will go on and give the different rows and columns a name. So if I do this, look how nice my matrix now becomes. I have column names and row names with the same values as above. Once you created your matrices, you can do very useful stuff with them. And as you'd expect, R has numerous built-in functions to perform matrix operations. Some of the most common are given below. For example, to transpose a matrix, we use a very advanced command called the transposition function, or T. Let's look what it does. If I take our created matrix, my mate, and assign it to my mate transposed using the T command, let's look what happens. It basically takes the matrix that we created. Let's look at the my mates to compare, so I can evaluate this. It took the data from the below matrix 1, 2, 3, 4 and transposed it, that is, flipped the matrix. So now the row becomes the columns, and the columns 1, 5, 9, 13 have become rows. This is a very powerful command, and we'll go back to this command in a future analysis. To extract the diagonal elements of a matrix and store them as vector, we can use the diag function. Let's go back to R, and on the mymat, let's look again at how mymat looks. We can use diag, and then it only takes the diagonal values, that is 1, 6, 11, 16. The usual matrix addition, manipulation, etc. can be performed in various ways and using various functions. Note that the use of the %% operator to perform matrix manipulations. Okay, we're not going to go over this. This is advanced stuff. Just that you know that there's a lot of very advanced functions that you can use for matrix calculations. We don't need to go over all of them, but be aware that other functions and mathematical operators are available. Okay, finally, a very useful, and this is what you're going to use a lot, is C binding and R binding. Matrices and datasets, which we'll learn up next, or databases, can be created using column binding or row binding with the C bind and the R bind command. Okay, let's look at an example. These are some of the most useful commands in R. I can create two vectors, X and Y. X is an integer from 1 to 3, and Y is an integer from 10 to 12. By combining columns, or cbind, of X and Y, and assigning it to CB1, I can create a matrix with an X, which is the X variable, and the Y. So it's binding two columns. Similarly, if I bind with rbind the two commands, or the two vectors, I will get a matrix with the first row being X and the Y being the second row. So we're binding rows in this case. Let's go over lists. The next data structure we will quickly take a look at is list, which is related to the other data sets or structures that we've talked. Whilst vectors, matrices, and so on are constructed or constrained to contain data of the same type, lists are able to store a mixture of data types. So I wasn't 100% honest with you saying that you shouldn't mix data types, but lists are very advanced. We're not going to cover lists during this semester, probably in the advanced data course, but the fact that you can store other data structures such as vectors and arrays within a list is very powerful. To create the list, I'm just going to show you some very simple examples. We can create the list function, or use the list function. Note that each of the three list elements are of different classes: character, logical, and numeric. and are of different lengths. So if I create a list with the list function using a vector that's character, a vector that's logical, and a vector that's numeric, let's see what happens. I created this, and now looking at this list, you can see we have the first element of the list, which is a character variable, the second element is a logical variable, and the third is a numeric variable. Note that in RStudio, you can see exactly that when you look at the environment variable and you look at the actual list. Character, logical, integer. So it's 3 separate vectors. Elements of the list can be named, of course, during the construction, so you can, name them while you do it. Or after the list has been created using the names function. So you use a new function called names. You assign list1 to that, and then you assign the vector of names to that list. Factor variables store the nominal values of a vector of integers in the range of 1 to k. Factors are used to represent categorical data. Factors can be unordered or ordered. Okay, so you can see this is a variable or a vector. You can see it has different objects with different values, but it has 4 levels: 1, 2, 3, and 4. A factor can also be character, of course, yes or no, right? The order of the levels can be set using the levels argument to factor. This can be important in linear modeling because the first level is used as the baseline level.